So this is the second tutorial and related to synchronous generators. So in this tutorial I will be solving 2 to 3 problems, and these problems will be mainly related to topics like the power angle of salient pole and round rotor synchronous generators and motors, etc. So the first question is related to a 3-phase 20 kVA synchronous generator, and what you have to do is that the phase voltage is given as 230 volt, while the synchronous reactance is given as 2.0 ohm, and the resistance of the armature for the phase A is given as 0.8 ohm per phase or 20 ohm per phase, and the power factor angle is given as 45.57. So the question for this is to find the voltage regulation. So if such a question is given, it is to find the voltage regulation for the generator, and this is taking into consideration this question is not related to any practical generator. It's only for showing the calculations. So first, if you have come across such questions which is related to finding the voltage EG or the generated voltage and also the power angle delta. So if you want to find these two, so if you come across such questions, the first step or the first approach could be to draw the phasor diagram. So when you are drawing the phasor diagram, what you will come across is there are multiple ways to start, but I will start by considering IA along the x-axis, and then I will draw the VA, and now I have drawn the IA, and this angle phi is equal to 45.57 degree. This is my power factor angle, and this is a lagging power factor. So in the question it is given as lagging. Now based on this, I know that my J of IARA and J of IA into XS are the two components, and what I get here is my EG or the generated voltage per phase, and this is my voltage per phase. So all these values are per phase values. So once you have this diagram, this is a step 1, and the step 2 could be to write the equations based on this diagram. So what you will get is, you will get your EG can be written as equal to under root of what I have here. So this forms a right angle triangle. So EG forms the hypotenuse of this triangle, and based on this it can be written as VA cos phi plus IA RA whole square plus VA of sin phi plus IA into excess of whole square. So this is the equation based on which I will get my EG, which is a generated voltage to find per phase. And this is for, again, from the question it is given that it is a round rotor machine. So now you have to find your per phase VA, which is equal to 230 divided by root 3, which comes close to 132.79, making an angle of 0 degree, and your IA can be found out from the power which is given, which is equal to 20 into 10 raised to 3 divided by 3, considering for only one phase, and when you will do it to root 3, what you will get is the power close to 50.20 amperes. So now when you have found out these two quantities, you can easily put it here. So when you will put it here, what you will find is (132.79) of cos of 45 degree plus IA, which is 50.2 into 0.8, which is my RA whole square, plus VA again, which is 132.79, and sine of 45 degree plus IA, which is 50.2 into XA, which is equal to 2 whole square. Now when you will do this, what you will get is equal to 236.09. So this is my EG. So my EG is equal to 236.09, and so now the question was to find, so the delta is, the question is to find the voltage regulation. So the voltage regulation can be given as EG, that is my no load voltage per phase, minus my load voltage per phase, which is equal to VA divided by VA into 100. So this comes close to 236.09 minus 132 divided by 132.79 into 100, which is equal to close to 77% or 78%. But if you are doing it though the value is very high for the voltage regulation, which should be ideally in the range of 2 to 3%, but since it is very high, what it shows is that while my no load, on load the voltage was close to 132. Well, at the load it went up to 236. So this shows that this machine is not designed very perfectly, but the calculation method is correct here. So I took some values which might not be very much correct, or but this was the first question. It was related to finding the voltage regulation of a round rotor synchronous generator when the values are given, or one of the possible ways. The other way is by knowing the angle of delta you can find the value of Eg, and the delta is a power angle. So we will see questions related to that. I'll and the next question is, for the same machine that is to find the power angle delta. So it's a 3-phase 20 kVA synchronous generator, and this is having what is known as a round rotor, and other details are the VA is equal to 230 volt and XS is equal to 2.0 ohm and RA is equal to 0.8 ohm per phase, and this is again per phase, and the power factor is equal to 0.779 and the phi is equal to 45 degrees. So these are the machine details. So based on this, the question is to find delta is equal to power angle. Now based on the last lecture, the last example, the EG was calculated close to 236.09 and the VA was found out as 137 or 132.79, making an angle of 0 degree, and the IA was equal to 50.20, making a minus 45 degree angle which was lagging. So this was lagging angle power factor. So now the question is to find the power angle delta. So how can you find it? So based on the details, it can be said that my VA or my VA is equal to my IAZS plus EG. So again, if you're writing that, what you will get is, you'll get, this is from the phasor diagram which I had shown just right now in the last problem. So it can be written as 132.79 making an angle of 0 degree equal to IA, which is equal to something like 50.20 into ZS, which is equal to XS plus RS, or RS plus JXS is equal to ZS, and you can get the angle based on this, and it will come close to 2.15 making an angle of, or 2.15 making an angle of 68.19. So when you are multiplying this to, the resultant angle will come close to 68.19 minus 45 degrees and plus EG, which is to be found out. So this will be 132.79. cos of 0 is 0, so it will be as it is, and 107.93 making an angle of 22.62 degree plus EG. So if you are expanding it, it will have 107.93 of what is my cos of 22.62 degree plus J sine of 22.62 degree is equal to my EG, or plus my EG, or 132.79. So when I will take this on the other side, what I will get is something like 231.62 plus J of 41.51, which is equal to my EG. And when I am resolving this, I will get my EG equal to 235.3 making an angle of, 235.3 making an angle of close to 13 degree or 10 degree, which is approximately equal to 10.61 degree. So in the last question which we solved for EG, so the EG was found as 236.09, and it was found directly from the graph from a different way. And in this method, although the details are the same given, but we have used conversion into the complex form to solve the same problem, and the answer found out here is 235.3 making an angle of 68.19 or 10.61. So this is my answer, which matches with what is found in the last, by computing using the last problem, and my delta here found is 10.61. So this validates that whatever method used here and what was used last time is correct, and the delta is found correctly. And again, this is a way of finding your delta or the power angle when you're knowing or considering your RS. So suppose if you are neglecting your resistance, so there is a formula which was done or which was derived in the previous lectures, and that formula was for the approximate power output per phase considering the phase of A approximately when you are neglecting the RA, which is greater than. So my RA was less than XS when it is very low as compared to the synchronous reactance. So it's possible to neglect this, and when you're neglecting that, you will get something like VA into EG divided by XS is equal into sine delta. So based on this formula, is it directly possible to find your delta? So in this case, in this very particular case, my RA was equal to 0.8 ohm, while at the same time my XS was equal to 2.0 ohm. But this is a very large difference if you are comparing. So since this is a very large difference, it's possible that your delta will be delta which was found by considering RA was close to 10.61. So in this case, if you are neglecting it, it's possible that it would be differing by somewhat larger margin. But again, trying for that, so my voltage per phase or the power per phase, if you are finding it, it will be like 20 into 10 raised to 20 into 10 raised to 3, 20 into 10 raised to 3, and this is my power, which is 20 to 10 raised to 3 divided by root 3 when you're comparing it for per phase. And if you are taking your VA per phase, and which was equal to 236.09 into 132.79 sine of delta divided by your XS, which is equal to 2.0. So this will come close to what is 20 into 10 raised to 3 divided by root 3 divided by 236.09 divided by 132.79 into 2 and sine inverse of answer, which will give you a delta of close to 47.44. But again, there's something wrong here, which you are getting a delta which is so different. So the computation is wrong here, which is we have not divided this by 3, which is converting it into per phase. So my answer was equal to 40, or sine inverse of answer was equal to, so again taking 20 into, and it will go to 666.66 divided by 3. So your delta in the other case will come close to 13.79. So this is the case when you are neglecting your RA. So it will come close to 13.79 is your power angle when RA is not considered. So again, drawing the same phasor diagram. So what you had was you draw your phasor diagram by considering IA, and then you draw what was your VA. So now what you get is your phi, which is close to what is 30 degree, and then you will get something like IA RA and this was what is your delta, and this was my O, and so this delta was found close to 10, and this was my EG and this was my VA. So now if you are directly to find, if you are even given the delta, then if you are to find your EG, so one way would be that EG of cos of phi was equal to 45 degree in this case. So cos of 45 degree plus 10 degree, which is equal to my VA cos 45 degree plus IA into RA. So based on that, it's possible to find your EG. So just to validate, EG of cos of 55 degree is equal to my VA, which I found out was 132.9 or 79, of cos of 45 is equal to 0.77 into 0.779, and plus IA, which was equal to 50.20 into RA, which was equal to 0.8. So 50.20 into 0.8, which was equal to 40.16, and your 132.79 into 0.779, which is equal to 103.443. So EG of cos of 55 is equal to 0.573. So 103.443 plus 40.16 divided by 0.573 comes up close to what is 250.16, while my EG, which was found out the other way, was close to something like 236. So again there is a difference, and the difference is probably because taking the angle of delta as 10 or 10.61. So again that's a way to find out the delta if you directly know it, or to find out EG when you know both your delta and your cos phi, which is given, and it can be found out as projection of this, and this on the x-axis, which will be again equal to projection of this. So again the mismatch has been found out as cos of 45 degree was equal to 0.707, unlike what we have taken here as 0.77. So this will be 93.89, and when I will find out my EG, it will come close to EG is equal to 236. So this is what again we found out. So when you have both your delta is given or the power angle is given and your phi is known or the power factor is known, and then you know your resistance and then you know your excess. So this is how you can find out the power angle, and the power angle curve gives what is known as the variance of power angle with the power P. So your power will be again equal to, or the relation between the power and the power angle can be again found out by this equation. If you are computing power directly equal to VA into IA, so you'll have to take into consideration how it is varying, or by directly using the equation which is relates power angle directly to delta. So when power angle will change, it is obvious that when this angle will change, it will not have much effect on what is happening to your VA or IA. When this angle will change, it will affect your EG. So based on how my EG will change, it's possible to see how my delta changes. So that's how the power angle is related to delta, and the equation, if you go through your textbooks or references, then there's an equation which relates power angle to delta, and that's how you can compute a power angle curve. So that was all what I wanted to say in this lecture, and